Have you ever looked up at the night sky and felt a profound sense of smallness? It's a feeling that connects us across cultures, across millennia. This vast, dark expanse, glittering with countless points of light, isn't just a beautiful backdrop. It's a laboratory, a time machine, a history book, all at once. It holds secrets so profound, so counterintuitive, that they challenge the very foundations of what we think we know about reality. The universe doesn't really care about our common sense. It operates on a set of rules that can seem bizarre, even magical, from our limited human perspective. Today, I want to take you on a journey, not in a spaceship of the imagination, but through the landscape of scientific discovery. We're going to explore some of the most mind-bending truths modern cosmology has uncovered. They stretch our minds, they provoke our curiosity, they remind us that the greatest adventure is the quest for knowledge itself. So, get comfortable, suspend your disbelief, let go of what you think should be true, open your mind to what the universe reveals is true. We're about to venture to the edge of understanding, to peek behind the curtain of the cosmos. And I promise you, what we find there will not only surprise you, it might just break your brain. Are you ready? Let's begin. We tend to think of the universe as everything we can see. All those distant galaxies revealed by our most powerful telescopes. We call this the observable universe, and it is staggeringly vast, about 93 billion light-years in diameter. But here's the first brain-breaking truth. Everything humanity could see is likely just a tiny bubble in a much larger cosmic ocean. The light from anything beyond that bubble hasn't had time to reach us since time began. Think of a small boat on the Pacific. Your horizon feels like the edge, but you know the ocean goes on. Our observable universe is that horizon. Our cosmic horizon is a limitation of light speed and time, not a physical boundary. Beyond it, more galaxies, more stars, more planets, perhaps an infinite expanse. The 2 trillion galaxies in our bubble could be a grain of sand on an infinite beach. We live inside a bubble of perception, humbling and exhilarating. Let's take an inventory of the universe. Stars, planets, gas, dust. All the stuff we can see, touch, and measure. Everything ever charted by any telescope at any wavelength of light adds up to a mere 15% of the total matter. The other 85%, we call it dark matter. We know it's there because we see its gravity. Like wind through trees, invisible, but its effects are obvious. Galaxies spin so fast they'd fly apart, unless a massive, invisible halo provides gravitational glue. Dark matter is the scaffolding of the cosmos, dictating where galaxies formed. A vast web of filaments and voids. We live in a universe governed by a substance we can't see, touch, or yet identify, the universe's biggest ghost story. For decades we debated, a big crunch or a forever coasting expansion. Then, in 1998, distant supernovae told us something no one expected. The expansion isn't slowing down, it's speeding up. Imagine throwing a ball that accelerates upward into the sky. Some mysterious force, dark energy, acts like cosmic anti-gravity, a property of space-time itself. The more space there is, the more of it there is, pushing expansion faster. If dark energy dominates, distant galaxies will slip beyond view, our sky emptying until only our local group remains. Add it all up. Dark energy is nearly 70% of everything. We live in a universe dominated by forces we are just beginning to comprehend. And stranger still, the enigmas only deepen from here. Black holes are already mind-bending, points of effectively infinite density. Gravity so strong, not even light can escape. One fundamental law: information can never be truly destroyed. Burn a book. In principle, the information is scrambled, not erased. But black holes seem like ultimate shredders. What happens to the information of everything they swallow? Hawking showed black holes radiate and slowly evaporate. Yet that radiation looks random. If a black hole evaporates and takes information with it, quantum mechanics is violated. If it escapes, how? This is the black hole information paradox. It pits general relativity against quantum mechanics. Solving it could spark the next revolution in physics. Imagine a sugar cube weighing as much as Mount Everest, or all of humanity. That's neutron star density. The corpses of massive stars, city-sized, maybe 12 miles across, packing 1.5 suns into that tiny volume. Gravity overcomes atomic forces. Electrons smash into protons. A sea of neutrons forms, a gigantic atomic nucleus held up by neutron degeneracy pressure. They spin hundreds of times per second, wield titanic magnetic fields, with an iron crust and superfluid, superconducting interiors. A single teaspoon would weigh billions of tons. It's matter, but not as we know it. In 2015, we didn't just see the universe, we heard it. LIGO detected gravitational waves, predicted by Einstein a century earlier. The first signal, two black holes, under 30 suns each, merging over 1 billion light-years away. A tiny chirp here on Earth. Space-time stretched less than a proton's width, yet it shook the fabric of reality. This opened a new window. We can now hear neutron star mergers, black holes colliding in the dark, the universe's most extreme physics. We are now listening to the cosmic symphony, a soundtrack of creation and destruction across billions of years. And if sound can rewrite our senses, quantum emptiness will rewrite our idea of nothing at all. What is empty space? Classical physics says nothing, but quantum mechanics says it's a roiling, bubbling soup of potential. Virtual particles wink in and out, measurable via the Casimir effect, even fueling Hawking radiation. Quantum fluctuations seeded cosmic structure. The universe, it seems, can't stand being empty. Exoplanets shattered our assumptions. Hot Jupiters skimming their stars with 4-day years. We found super-Earths, diamond worlds, planets where it rains glass sideways, tidally locked infernos and ice, even rogue worlds in darkness. Over 5,000 confirmed and counting. Planets are ubiquitous. The universe is a celestial zoo. The cosmic microwave background, the universe's baby picture, even flickers in old TV static. 380,000 years after the Big Bang, the universe cooled. Atoms formed. Light was set free to travel for 13.8 billion years. Astonishingly uniform, yet minuscule temperature ripples became the blueprint for all galaxies, stars, and structures. We feel time as universal, but Einstein showed time is relative and elastic. Gravity and speed stretch and squeeze time. GPS works only because we correct for time dilation, 38 microseconds per day. The closer to mass, or the faster you go, the slower your time runs. Time is personal, not universal. Some theories suggest a multiverse, endless bubble universes, parallel brains, or branching quantum worlds. Not established facts, but logical consequences. With trillions of worlds, life should be common, yet the skies are silent. The Fermi paradox. Where is everybody? Perhaps life is rare, intelligence rarer, or self-destructive, or maybe we're among the first wave of consciousness. We are stardust, the iron in our blood forged in dying stars, given the ability to contemplate the stars. Don't just see points of light, see the questions, see the mysteries, see the incredible, brain-breaking reality we are part of.